Shruti, and a little background. I did my BTech from IIST Shipur in Aerospace Engineering and Applied Mechanics, and I have done my Masters from IIT Bombay in Aerospace Engineering, specialized in propulsion. So today we'll be seeing jet propulsion introduction. So here are the topics which can be covered. Um, we'll start with the basics like what is definition of propulsion, and basically jet propulsion is concerned with the aircraft propulsion, like air breathing engines. Mostly we deal with that, and the other contradictory part is the non-air breathing engines, which are rockets. So we should understand what is the basic difference between these two. In air breathing engines, there are various aircraft engines like turbojets, turbofans, turboprops, which are used, and we'll see what are its features, where it can be used, like based on its flight envelope, where at what altitude range can be used, at what Mach number we can use a specific engine. We'll also see how to quantify its performance of an engine based on its thrust production or its efficiencies, and what is specific fuel consumption. We'll see these are all the performance parameters in order to quantify the performance of an engine. Then we'll any kind of engine works on a thermodynamic cycle. So we'll understand the thermodynamic cycle of each engine, and we'll see ideal versus real cycle comparison. So ideal cycles are those in which we assume that it is behaving perfect. Like all the processes that are happening, they are happening without any kind of losses. So it gives you a measure of the upper limit of how well can an engine perform. But basically, in actual scenario, there are losses, and there are efficiencies of each part of an engine. Like there is compressor, there is turbine, combustion chamber. So each part has a specific efficiency. So there are losses in each component. So the real cycles behave differently from the ideal ones. So we'll see a comparison. Then we'll move towards turbo machinery, like the rotating components such as the compressors and turbines. There are various types of compressors and various types of turbines as well. We'll see how to estimate its performance also. And apart from compressors and turbines, there are few more components like intake, nozzle, and combustion chamber, which we'll see separately. These are the reference books that can be used in case you want to refer to jet propulsion. However, the second reference book is for rocket propulsion. So let me begin by sharing you the definition of what is propulsion. So propulsion is basically uh, a generation of thrust in order to propel an object by ejecting mass from the vehicle itself in the opposite direction. So propulsion basically works on the third law of Newton. Like every action has a equal and opposite reaction. So what it does is it produces thrust. But the main a key point here to see is, or to highlight is, it is producing thrust by ejecting its own mass. So vehicle will consist of some sort of mass which is utilized in order to create a motion, and this mass is ejected in the opposite direction, and the propulsion is given. So for a simple, in order to understand the jet propulsion system, balloon is a very simple and basic example, just to clear the concept. However, I would like to ask a question, whether can we say automobiles, the way automobiles move, can we consider it as an example of propulsion? So here, what I'm trying to say is, I'm going to discuss various examples of propulsion, like torpedoes, motion of fish, and ducted systems. Balloon is also one kind of an example of propulsion, but can we consider automobiles to be a kind of propulsion or not? Is a question. Can someone brainstorm over it? In order to answer my question, you just have to look at the definition of propulsion. Like it is the thrust is being generated by the object by ejecting its own mass. So, can we consider an automobile system to be an example of propulsion or not? Okay, so I have got few responses. So let me begin by you will know whether your answers are correct or not by the explanation that I'll give now. So let me begin by explaining how a balloon is getting propelled. So balloon is a simple system, a thin plastic sheet wherein there is gas that is filled. This gas is usually lighter than air. So when there is an opening of the balloon, this gas is basically is ejected out, and due to this ejection of the gases that is being filled in the balloon, it creates a chaotic motion. So the main component main reason for the propulsion is the chaotic motion of the gases that are being ejected. Similarly, when we look at the automobile system, let's say this is a reference line for the ground, and let me consider this to be the wheel of an automobile system. So this wheel is basically going to rotate, and it is going to make the vehicle move in a forward direction. But whatever the motion that is being transferred to the wheel is by the mechanical linkages. These are mechanical linkages which is transferring the motion to the wheels, and then this wheels is creating a forward motion for the vehicle. So here the reason of the motion is the transmission of forces through the mechanical linkages. So this cannot be considered as an example of propulsion, because there is no ejection of mass that is happening, which is basically the reason of the forward motion. The reason of the forward motion is just the involvement of mechanical linkages, which is transferring the forces. So automobiles, although it is getting a forward motion, although it is moving, but we cannot consider it as a under the definition of propulsion. Similarly, these are few examples which we can consider. So here, let us consider a small control volume. This dotted rectangular box is the control volume that I'm considering. Here what happens is, due to this propeller blades, the motion of the propeller blades, the fluid is being sucked in from all the directions, and then it is getting sucked. Then it is getting sucked out of of the control volume. So because of this presence of fluid plus the motion of the propeller blades, the mass that is the flow of the fluid is getting generated. So here also we can consider this as an example of propulsion device, because there is the mass that is getting entered is being rotated by the propeller blades, and uh, the difference in the energy is giving the forward motion to the torpedoes. Similarly, when we consider the motion of the fish, the tail of the fish, the motion of the tail of the fish will create a jet-like structure behind behind itself, and because of this jet formation, it is getting a forward motion. So it is similar to a torpedo, wherein a jet stream is created behind the fish due to its motion, and but still here what is the reason behind its propulsion is because of the presence of flow field. If there was no flow field, there won't be any kind of motion. So it does not have its own mass. It does not have its own mass, but it is sucking in the mass and then it is ejecting that mass out, and because of that ejection, it is getting a forward motion. Similarly for the fish. For the ducted system, the air that is intake plus the fuel that you provide in a combustion chamber, when the air plus fuel burns, it produces hot gases which comes out of the system. So we are taking in some of the mass, we are adding some of the mass here, and there is the ejection of the entire mass of the system. And because of this ejection, because of this difference, there is a forward motion of the engine. Similarly, rocket engines, it consists of both fuel and oxidizer inside its own system. And because of this, when it burns, because of the production of hot gases, it is ejecting in the opposite direction, and it is getting a forward motion. So all these types of examples are can be considered as a propulsion examples. I hope it is clear. Okay. So now moving forward, we will discuss what are the differences between the air breathing and non-air breathing engines. So basically, from the name itself, you can say that these air breathing engines, they use the atmospheric air for the combustion, whereas in non-air breathing engines, the air is not being intake from the atmosphere. It carries its own oxidizer as well as fuel. So air basically acts as an oxidizer, whereas fuel is given in air breathing engines. But in case of non-air breathing engines, both fuel and oxidizer will be carried by itself only. So the examples can be, as we know, turbojet, turbofan engines which have a big air intake. They take in the atmospheric air, and then the combustion happens and the hot gases are formed. Whereas in non-air breathing engines, examples could be rocket engines. So here, oxidizer and fuel could be in various state, like There can be solid oxidizer and solid fuel. There can be liquid oxidizer and liquid fuel like cryogenic engines. So these are the examples. Coming to other feature, that is oxidizer source. So as we discussed, the oxidizer source for air breathing engine is atmospheric air, whereas in non-air breathing engine it is stored on board. For example, ammonium perchlorate is an solid oxidizer example. All these things you can just physically see in the engine and you can differentiate. So these are very basic differences that I'm sharing. Whereas fuel sources, now fuel source for an air breathing engine, usually we use jet fuels or kerosene. They are basically types of kerosene only. Jet A1, RP1 fuel. Those are aviation fuels that we call, which are carried on board only. We carry the fuel, but we take in the oxygen from outside. Similarly, for non-air breathing engines, there is liquid hydrogen or there are solid fuels like HTPB, which is carried on board. The operating medium. Now, air breathing engines, they do require atmospheric air in order to operate, whereas non-air breathing engines can operate also in vacuum condition because they do not intake any sort of air. So, can someone tell me what should be the altitude range of using air breathing engine or non air breathing engine? First, let us have an answer for air breathing engine. What should be its altitude range or operating altitude limit, sort of? So, based on the operating medium itself, we can comment on the operating altitude range. Basically, air breathing engines will require an atmosphere. So it is very much limited within the Earth's atmosphere. Whereas non-air breathing engine, it doesn't bother like. So it can operate both in atmosphere as well as in space. If we talk about the speed range, then air breathing engines are limited to subsonic, supersonic, and sometimes they go about hypersonic speeds. Whereas non-air breathing engines require a lot of higher speed because they do interplanetary missions, they go towards space, so they have to at least reach orbital velocities. So they go at much higher speeds. These are very basic differences that we have discussed. Now, moving forward, other features such as the mass of propellant by the weight of the aircraft. MP by W represents that mass of propellant divided by the weight of the vehicle. So, mass of propellant as in mass of the air plus fuel in case of air breathing engines, whereas non air breathing engines, we call whatever the fuel and the oxidizer are stored inside the rocket, we call it as a propellant. So, here we see that the air breathing engines, usually the air to fuel ratio is basically 15 to 17. So, whereas the mass of propellant by weight of the non air breathing engines, usually whatever the structural mass of rocket is there, it only comprises of 20%. The total rocket weight, it has more propellant than its structural mass. So 80 to 90% we load the rocket with the propellant itself. So I want to just say comment on the acceleration part of the air breathing engine and non-air breathing engine. So what happens is when you consider a scenario of cruising where the air breathing engine and non-air breathing engine are in the cruise phase. So in cruise phase, mostly the force or the thrust remains constant. When we talk about air breathing engines, as we know, force is equals to mass into acceleration. So here, what happens is the fuel is getting consumed. Fuel which is on board, which contributes to the weight of the vehicle, is getting consumed throughout. But the as we have seen, air to fuel ratio is 15 to 17. That means the contribution of fuel in the weight is very negligible. We are using fuel compared to the air very much low. So whatever uh, changes that are happening in the mass of the vehicle is very negligible like when we see, because the fuel quantity is very small when we consider in air breathing engines. So we can say that the acceleration almost remains constant, it doesn't change much. But when we go towards non-air breathing engines, then this mass of the vehicle consists of 80 to 90% of the propellant. So by the time it gets consumed, right? So this mass varies drastically throughout its trajectory. Hence acceleration also varies when we consider its trajectory, when we compare both air breathing and non air breathing engines. Similarly, when we talk about T by W, where T is nothing but thrust by weight of the weight of the engine. So thrust to weight ratio of air breathing engine is usually 5 to 1 or 7 is to 1. Whereas in non-air breathing engines, it has to produce lot more amount of thrust in order to cross the Earth's atmosphere and go towards the space. So the thrust to weight ratio is much higher for non-air air breathing engines. When we move towards the other feature, like thrust to frontal area, AF represents frontal area. Frontal area means whatever is seen if we put a perpendicular projection of the engine, like when you see the turbo fan engine that is hanged below the wings of the aircraft, whatever perpendicular projection you can see that frontal area. And of the rocket, if you compare, so we see that these air breathing engines are very much bulky in nature because they have to consume lot of atmospheric air. So in order to intake more amount of air, they require a large frontal area. Whereas rockets, they don't have any sort of intake, so they are very slender bodies. Slender means, as we know, length by diameter of any object is called the slender ratio. So the length is much higher than the diameter of the rockets. So these are very slender bodies. So whenever they are traversing in the Earth's atmosphere, that is when the drag is going to be experienced by the rocket because of the flow of the air that is coming. So this drag is basically very much lower when it is experienced because the frontal area is much lower. Whereas the thrust production of non-air breathing engine is much higher. So for air breathing engines, since it is bulky in nature, it will produce more drag compared to the non-air breathing engines. Now moving towards vehicle exit velocity dependence on the flight velocity. So when we write thrust equation, so there is something that is getting ejected out, which contributes to the exit velocity, and there is something UI, that is intake. Let's say it is the flight or the engine intake velocity. So for air breathing engine, since it is in since some part of the air is getting intake, so there is a dependence of flight velocity also. whatever will be the flight velocity of the object, that will affect your thrust, because that is going to contribute in the amount of oxidizer that is going to go inside. Whereas in case of non-air breathing engine, there is no relation, because there is no air that is coming inside the rocket. So only the exit velocity of hot gases. So thrust depends only on the exit velocity of the hot gases. So for positive thrust, flight velocity should always be less than vehicle exit velocity. As we can see from this equation, if Ui becomes higher, there will be a negative thrust. It will contribute to drag. So in order to have a positive thrust, UE should be greater than UI. Whereas for non-air breathing engines, there is no relation as such. So now let us see what are the applications of air breathing and non-air breathing engines. So here turbo engines are basically, as we have seen in our day-to-day lives also, many of you must have traveled in aircrafts. So these aircrafts like civil and these turbo engines are basically used in civil and military aircrafts. Military aircraft as in fighter aircrafts. So their purpose is basically for transportation of passengers or cargo, or military aircrafts are basically used for combat during wars. So depending on the application of the turbo engines, uh, the usage of turbojets, turboprops will be decided. So based on the requirement, let's say since military aircraft have to perform lot many maneuvers in their entire flight trajectory, there will be certain engines like turboprops which can never be used, because turboprops can be applicable only for low altitude application. Because as we go higher, whatever drives the turboprop basically have propellers. So whatever drives the propellers, that is the uh, mass it which is present in the atmosphere. When we go towards high altitude, the density of the air reduces, and the amount of mass that is going to be present, or that can be taken by the propeller, will go down. So it will not be sufficient to overcome the drag that is being generated by the engine. So depending on the altitude and depending on the speed with which you want to operate your aircraft, you have to choose uh, which engine can be applicable. Like turbojet engines are highly flexible, and they can reach up to Mach 2. So fighter aircrafts mostly they use turbojet engines. Whereas civil aircrafts, you must have seen when you must have traveled in aircraft, that there are huge fan blades which are there present at the start of the engine. So these are basically turbofan engines that are being used. They have a huge turbofan at the beginning, then there is compressor followed by the rest of the components. So depending on the flight trajectory, depending upon the operating altitude and the speed with which the entire aircraft needs to travel, we will choose what sort of engine is best suited, which will give the best efficiency and best performance. The other ram-based engines, such as ramjets and scramjets, they are basically used for in case of missiles. The main purpose to serve is to sustainer phase of missile. Sustainer phase as in, it's like a cruise phase wherein the thrust is more or less the thrust whatever is being produced by the engine is sufficient to just overcome the drag that is being produced by the missile. So in this case, sustainer phase, we do not want the missile to accelerate. We want it to travel in a constant velocity. So the thrust that is going to be produced will be just sufficient to have a constant velocity for a prolonged duration. In such application, we are using RAM-based engines. But in order to have a ramjet or scramjet in a working condition, we require Mach number to be at least greater than 2. Then only it can be operated. We will see why, we'll see the reason behind this limitation. Whereas non-air breathing engines are used as a launching vehicle, interplanetary mission, and in some cases we use it for use it as missiles also, where it goes in the outer space and then comes back like a re-entry vehicle. We can use non-air breathing engine in that case. In future, we can use it for space tourism as well. So is there any doubt in between any point? I'll just go back through the slides so that in case we have any doubt in any point, we can clear that now. If things
See,
are
I
clear, I
think
would
no
like
doubt.
to move towards numericals. Sorry, some questions that we can see based on the current class. So this was a previous year question that was asked. So in a scramjet engine, the Mach number at the entry to combustion chamber is around. Can someone answer? Johit, can you also specify the reason why is it so? So C is the correct answer, but the explanation could be given like scramjet being scramjet is a RAM based engine. So what does scramjet stand for? Supersonic combustion ramjet basically. So here whatever combustion that occurs can occur at a supersonic speed. So based on its definition itself, we can answer this question that Mach number of 2 can be the Mach number at the entry to the combustion chamber for a scramjet engine, whereas a ramjet engine undergoes subsonic combustion. So whatever high supersonic speed, let's say Mach 2, which is being entered in a ramjet engine, they will basically in the combustion chamber it will slow down to subsonic speeds before the entry. Whereas in scramjet, as it says supersonic combustion ramjet, the Mach number at the entry to the combustion chamber is 2. Other question, thermodynamic cycle on which the jet engine operates can be. what does thermodynamic cycle mean? It involves a series of operations wherein the thermodynamic properties of the working fluid has been changed. So basically, a jet engine, which is a gas turbine engine, also we can say, it operates mainly on open Brayton cycle because every time it takes in fresh air and it ejects out the gases. So it is not a closed it cannot operate on either open or closed, but it is always operating at an open Brayton cycle condition because every time it intakes new fresh air and it ejects out hot gases. I request everyone to please work this out and share an answer. It asks that for the given aircraft, what will be the engine that can give you the most efficient performance? Yes, the correct answer is D indeed. So here the low speed transport aircrafts, those are the civil aircrafts that are being used. For this, turboprop engine can be used. So low speed, bec- because when we are using propeller blades, what happens is if we try to go at a higher speed, at the tip, it can reach up to Mach number greater than 1. Because of its own motion, the air will speed up at the tip of the propeller blades. It can go up beyond Mach 1. So when it goes beyond Mach 1, it experiences some sort of supersonic drags. Like presence of shock waves will be there, which is not suitable for a propeller blade. It can also cause some structural failure of the propeller blade. So, as it is said that transport aircrafts are operated at low speed, we can very well use turboprop for the most efficient performance. But when we move towards high subsonic civilian aircrafts, then we might want to go for turbofans, which are currently being used in A320, A380, A320 aircrafts. Whereas in case of supersonic fighter aircraft, since it has to supersonic fighter aircrafts needs to have a slightly lesser bulky bodies. Like as you have seen, civilian aircrafts are much huge in their frontal area and all. So it produces large amount of drag. Whereas supersonic like fighter aircrafts, when it travels in supersonic speed, if it has a bulky body, it can produce tremendous amount of drag. So we cannot install turbofan engines because turbofan engines usually have a much higher frontal area than compared to the turbojet engines. So and also it has to have a high maneuverability in case of dog fighting and all. So we use turbojet engines mostly, and turbojet engines, as I said, it can operate up till Mach 2 to 3. So it will be most efficient. And hypersonic aircrafts, ramjets can be used because ramjets are the most efficient when it comes to uh, speed limit greater than Mach 2. It basically starts its operation at Mach number greater than 2. So this is it. I I hereby end the class. In case of any doubts, we can discuss.
Yeah, thank you, Shruti. So, guys, you have any doubt? So, this was just introduction for propulsion part, and there are some questions from previous years we have taken. So, if any doubt, you guys can ask quickly. And as already informed, classes will start from November 5th. Okay, so for currently propulsion, we have Shruti along with Aksheshar is also there, and Dheeraj is also taking, gas dynamics and rocket propulsion part. Along with that, for GD, we have S. Kumar sir, and aerodynamics is already one demo was taken by Sanjay. Along with him also, we have one more person. So each and every subjects will be taken by individual subject expert guys. So we can wait if you guys have any doubt, either technical, non-technical, and already informed prior, shared to you guys some basic subjects lectures along with general aptitude. So till November 5th, you guys can utilize your time to prepare well for general aptitude using IGC lecture series along with basic subjects, and then we'll be starting our journey. Okay, fine. Shivam, any doubt? Saran? So Shruti, you have tomorrow class, right? That problem practice class. So you
Yes, sir.
can wind up. You can, leave. I will just talk if they have any concern or doubt.
Okay, sir. Thank you, sir.
Thank you. Thank you for your time. So how was session, guys? Just to tell you guys.